Here I'm going to look at a Leaving Cert question from 2012 dealing with coordinate geometry of the circle. So in this question we're given two circles and we're given the equation of both. We're asked to find the centre and the radius of both. As I've described in a previous video, to get the centre when the equation is written in this format, we just take minus half the x coordinate and minus half the y coordinate, and that gives us our centre. So for the circle 1 it's going to be 3, 5, and the radius will be the square root of g squared plus f squared, which is 3 squared plus 5 squared minus c. Well, this is c, so it's going to be minus 29. So the radius is the square root of 5. For the second circle then, the centre will be minus half of that and minus half of that for our x and y coordinate, and the radius will be 1 squared plus 1 squared plus 43 and the square root of all that, which is square root of 45, which is 3 times root 5. So these are our two radii. Circle 2's radius is 3 times the size of circle 1. The next part of the question asks us to verify that circles touch. Well, there are two scenarios where the circles touch. They can touch externally or touch internally. If they touch internally, then the distance between the centres is equal to the difference between the radii. If they touch externally, then the distance between the centres is equal to the sum of the radii. So we take the centres and we work out the distance using the distance formula here, and that gives us a distance of 2 root 5. And because we know 2 root 5 is equal to the difference between 3 root 5 and root 5, i.e. the difference between our two radii, we know that the circles must touch internally. The next part of the question asks us to verify that there is a point of contact, and the point of contact is 4, 7. Well, we already know they touch internally, so this must be where they meet. Well, if 4, 7 is on circle 1, then we simply substitute in 4 for our x value, and we substitute in 7 for our y value, and it should satisfy the equation. I.e., when you substitute in 4 and 7, everything on the left should equal to 0, which is on the right, which happens on both. So 4, 7, it must be on both circles, so it must be the point of intersection. The last question here asks us to find the equation of a common tangent. Well, I talked through this in a previous video. To find a common tangent, you simply subtract the equation of one circle from the equation of the other. And so when we do that, we're left with minus 4x minus 8y plus 72 equals to 0. We can just tidy that up by dividing everything by minus 4. X plus 2y minus 18 is equal to 0. That's the equation of the common tangent. It's usually written as x minus h to be squared plus y minus k to be squared. So in this instance, the centre is going to be 1, because that's written in the correct way. But as this is y plus 6, the y coordinate of the centre must be minus 6, and the radius is equal to the square root of the number on the right hand side, which is the square root of 360, which is the square root of 36 times the square root of 10, which is 6 root 10. In the next question, you're asked to find the coordinates of the centre of the smaller circle when you're told that the radius of the smaller circle is 1/3 of the radius of S, the larger circle. So the radius of the larger circle is 6 root 10, so the radius of the smaller circle must be 2 root 10, because it's a third of that. So this question involves dividing a line this question involves either dividing a line in a certain ratio, which is gotten in the formula, or else using a translation. We know that from the point A to the point B, that's 1 unit, and we know that that radius is 1/3 of the entire radius, so this proportion from K to A must represent 2/3, and that one represents 1/3 there. So I've represented that down here, where B is 7, 12, A is 1 minus 6, and K is somewhere in between, but we know the proportion along the line at which it lies. It is 1/3 of the way along here and 2/3 the distance from A. So in reality, it probably lies around here. So where this distance represents 1/3 of the entire distance from B to A, and this distance represents 2/3 from A to B. So we have a look and see what's happening to the x coordinate. On going from B to A, we know that there's a drop of 6. So it goes down by 6 from 7 to 1. Well, on going from B to K, we know that only represents 1/3 of that entire drop by 6. So it's going to be 1/3 times minus 6, which is minus 2. So, in other words, our x-coordinate of k is going to be 2 units down from 7. So it's going to be 5. And for y, we know that the y-coordinate goes from 12 to minus 6. That's a decrease of 18. We know that k lies 1/3 of the way along the line from b to a, so therefore the jump on going from b's y-coordinate to k is only going to be 1/3 of 18, which is down by 6. So the y-coordinate of k will be 12 minus 6, which is 6. So therefore, writing the equation of c, we can just say if its centre is 5, 6, then the equation will be x minus 5 to be squared plus y minus 6 to be squared times the radius squared. Well, the radius is 2 root 10, so 2 root 10 squared is 4 by 10, which is 40. You're then asked to find the common tangent between the two. Well, to do that, we could actually just expand out the equation of c, expand out the equation of s, and just subtract them from each other. Or else we know that the equation of a line is gotten from the formula in the tables. We also know that the slope is going to be perpendicular to the slope of AB. That's the slope of our tangent, because the slope of AB is at the radius here. So the slope of the line, which is a tangent to these two circles, is going to be perpendicular to the purple line I've drawn there. So therefore the slope of AB is equal to 3, so the slope of the perpendicular to that is going to be minus the reciprocal, so which is minus 1/3. And we know it contains the point B, which